Hello everyone and welcome to the Thorogood webcast on the new and latest features in SQL Server 2016, Microsoft's latest release of SQL Server. In this webcast, we'll take you through the evolution of SQL Server over the years and how Microsoft continued to hone it into a cutting-edge enterprise data platform. We'll also demo some of the most exciting features that have come through with this release. We'll start with some brief introductions. My name is Arshad Taylor. I'm a business intelligence and analytics consultant with Thorogood Associates. I've been working for Thorogood for a number of years on enterprise business intelligence implementations across different technologies, in particular Microsoft and Tableau. I'm joined today by my colleague Ahmad Nategh, who is also a business intelligence and analytics consultant. Ahmad is a co-presenter for today, and we will both demo different aspects of what's new with SQL Server 2016. We have two chief objectives for today's presentation. We'll take you through the recent history of SQL Server before diving into the latest new offerings within SQL Server 2016. We'll also demo some of the features we find most compelling in this release, so you can expect this session to be pretty demo heavy. In our agenda for today, we'll start with a brief introduction to Thorogood. We'll then talk about the overall Microsoft roadmap at a high level before closing in specifically on SQL Server 2016. Once we get to SQL Server, we'll focus on the traditional layers, the core relational database, the reporting services module, the analysis services where you do your data modeling, integration services where ETL is performed, and finally some of the other less central components of SQL Server. What we hope to achieve in this webcast is capture all of the advancements in SQL Server in one place, so you have a single point of reference for the latest developments. We've also included a number of demos in this presentation to give you a good feel for the new features. For those of you who don't know Thorogood Associates, we are an independent global professional services firm specializing in business intelligence and analytics strategy, solution, and services. We've been around for over 20 years and place a keen focus on delivering value for our customers. As a global firm, we have offices in New York, Philadelphia, London, and an office in Bangalore, which we opened in 2004. All of our consultants are recruited and trained in the same way to develop a unique mix of skills. We blend business understanding with strong technical aptitude and a deep understanding of analytical tools and techniques, as highlighted in the intersection of the three circles on the screen. This intersection plays a key part in our ability to deliver high-quality business intelligence solutions. The range of services that we offer is holistic and covers the end-to-end lifecycle of any project, from initial technology strategy and roadmap definition, to requirements gathering and analysis, to the design, implementation, and testing of complex systems, all the way to the training and support of business users. On this slide, we've included a selection of our customers by industry sector to help you get a sense of the type of companies we've helped with their business intelligence and analytics needs. We work across a number of different industries, prominently the consumer goods, pharma and health services, insurance, and banking industries. Thorogood are an independent consulting firm in that we don't work with any one specific technology. We do, however, partner with a wide array of technology firms in the market, including back-end, front-end, and analytics-driven technologies. But a key interest for us today, as we'll be focusing on Microsoft's flagship enterprise tool, is our Gold Certified Partner status with Microsoft. We've been a Gold Partner with Microsoft for over 10 years now and are certified for data analytics and BI solutions, as well as intelligence systems such as SharePoint and cloud-based software. Our partnership gives us a great interface into the Microsoft development team. Not only can we get an early understanding of their thinking around their product roadmaps, but we also input into the direction of their products. We can feedback into early betas and pre-releases, as we certainly did with Power BI Designer, which you will now know as Power BI Desktop, and the Power BI Online service. We're also part of a number of their programs listed here. If you're interested in working with us on any of the innovation programs on the screen, please let us know. Now let's get into the Microsoft product suite and SQL Server's place in it. We believe Microsoft's product suite can be bracketed into three broad categories. Productivity and collaboration sees your popular enterprise applications like SharePoint and Excel, which I expect a lot of you will be familiar with. Meanwhile, Microsoft continue to work very hard on enhancing their cloud services, that is, their software as a service, infrastructure as a service, and platform as a service offerings. You will notice the presence of Azure products in this category, as well as the inclusion of the new reporting tool Power BI. In between all of this, you have the products which we collectively refer to as Microsoft's traditional on-premise data platform, SQL Server. You'll see over here the different components of SQL Server, as well as some newer entries like APS or Analytics Platform System and Mobile Report Publisher, which we'll get into in more detail later on in our presentation. The objective of this session is to focus on this middle section of Microsoft products. We'll talk about how these components have moved forward with SQL Server 2016, and we'll also demo a number of the new features. For more information on any of the other products in the Microsoft suite, feel free to check out some of our other on-demand webcasts online, or join one of our in-person workshops where we cover the entire Microsoft roadmap in much more detail. Now, before we get into the details of what's new with SQL Server 2016, let's take a step back and walk you through a typical enterprise implementation of SQL Server. In any enterprise, you could have myriad data sources from which you'd like to extract, transform, and load data into a centralized data warehouse. SQL Server Integration Services, or SSIS, is a tool which allows you to perform this integration by building ETL, or Extract, Transform, and Load solutions, which you can use to clean up and load data into your SQL Server relational database. In addition to SSIS and the relational database, Microsoft offers two other components within SQL Server: Data Quality Services, or DQS, and Master Data Services, or MDS. DQS is essentially a spell checker tool which enables you to cleanse, match, standardize, and enrich data. Master Data Services is a master data management tool which you use to manage entities and relationships between those entities. Once you've loaded your data into your relational database, you may want to create a business or reporting model on top of it to structure the data for reporting purposes. This is where Analysis Services, or SSAS, which is SQL Server's online analytical processing platform, comes in and allows you to do so with great levels of depth and complexity. Before SQL Server 2012, Microsoft only offered you the ability to build multi-dimensional OLAP cubes using SSAS. But with SQL Server 2012, they introduced the Analysis Services tabular model to the already existing multi-dimensional engine. And the tabular model allows you to build models a lot more quickly and query them in memory. The final piece in the SQL Server jigsaw is SSRS, or Reporting Services, which provides you a range of ready-to-use tools and services to help you create, deploy, and manage reports for your organization. So now that we've talked about a typical enterprise implementation of SQL Server, let's now focus on what we believe are the key gains that Microsoft have made with the release of SQL Server 2016 compared to what was in previous releases. Based on our assessment, we identified the following main areas. Scalability and performance see big improvements. In-memory performance, both on the Analysis Services and relational database engines, have been given a significant boost. Microsoft have also strengthened the bridge between on-premise SQL Server and the cloud, so it's now much more easily extendable to Azure. With SQL Server 2012, Microsoft released TDE, or Transparent Data Encryption, which was a good security feature. With SQL Server 2016, we see them building further on this with the release of Always Encrypted, which we'll demo shortly. Row-level security, which was another common feature requested by the user community, also sees its debut in this release. The overall user experience in general has been refined, both for end users and the consumers of information and developers of solutions. Reporting Services in particular sees an altogether new look, feel, and functionality. SQL Server 2016 also sees Microsoft building on its business intelligence and advanced analytics capabilities to a large extent. The integration of R with SQL Server is a promising sign on the analytics front, and from a business intelligence perspective, richer visualization and modeling capabilities are available in Reporting Services and Analysis Services respectively. Now I'm going to hand it over to Ahmad, who will take us through the advancements made in the Reporting Services and relational database components of SQL Server 2016. Take it away, Ahmad.
Thanks, Arshad. Hi, everyone. So as Arshad mentioned, we'll start by taking a look at the front end of the stack, Reporting Services. And so we're going to go ahead and jump onto the portal to take a look at that. You might already be familiar with Reporting Services. It's Microsoft's traditional reporting tool. It allows for heavy customization by a developer as well as embedding code, but it's traditionally more for structured reporting and isn't very interactive. Previously, you'd either access these reports directly or through a SharePoint interface if it was in integrated mode. In 2016, they've made a brand new portal, which you can see up on the screen here. If you're familiar with the old Reporting Services server, you'll notice it's a much more modern and sleek interface now. It's something that you can use instead of uploading to SharePoint, which is what a lot of people used to do before to avoid the clunky RS server interface that used to be there. As well as seeing your traditional RS reports, which are under the header paginated reports here, we've also got, it lets you bring together those reports together with your key KPIs at the top, your Excel, Power BI, and mobile reports as well. It also lets you pin your RS reports into Power BI. And ultimately, I think they're aiming for this to be the one-stop shop for all of your Microsoft reports. So on the portal, you can see the KPIs at the top, and you can create these directly here by pointing to a shared data set. that you've uploaded. And when I click on it, I can see which dashboards are related to this. So here I've linked it to the market share dashboard, and if I want to look at that market share KPI in more detail, I can click through and look at the dashboard for that. And what it's opened here is the mobile report. But as you can see, the mobile report works well in desktop as well. It's just that it's more customized for a mobile experience with its large icons. And so in the mobile BI space, Microsoft acquired DataZen last year, and they've rebranded it now with reporting services in 2016. The DataZen development environment is now called Microsoft Mobile Reporting Publisher, and the DataZen server is now being integrated with the RS server. So now you can publish your mobile reports directly to the RS server. And if you're interested in learning more about Microsoft mobile reporting, we do have an on-demand video up on the site that shows DataZen in a bit more detail. But as you can see here, it is a more interactive experience than the traditional RS reports, and you've got visual filters, and once you select one of them, they'll filter through to different charts, and it's more of an interactive experience. And RS does have a few new features in the paginated reports, like you've got charts like tree maps and sunburst charts, which weren't there before. You can see the tree map here, as well as a few new features which I expect are quite useful to quite a few people. For example, you can export your reports to PowerPoint now. So you can annotate it with your comments and provide a narrative around the reports and share that with other people in your organization. And also I can pin this to my Power BI dashboard from here as well. And finally, you can also select which are your favorite reports. So here as a marketing manager, I've selected the market share KPI and the market share dashboard, my favorites, and then a favorite screen where it shows me the reports that are relevant to me. So as we saw with reporting services, we've got a few new features specifically on the reporting side, like new charts and updated report builder interface, but really the key point here is the move towards being able to consolidate all your different reports in one place. And now we're going to go on to take a look at the core database side of SQL. So in 2014, we saw Microsoft making very conscious updates to their core database product, and the headline feature was Hackathon, which was an in-memory optimization of SQL Server to boost its ability to handle big OLTP workloads. They also introduced the ability to create in-memory tables and in-memory indexes in addition to disk-based objects. This was a stab at improving querying performance in the relational database. Another feature was the ability to make the BI indexes updatable, which was a welcome feature that gave enhanced performance and throughput to the end users. There were enhancements around high availability as well, and an initial move towards allowing storage between on-premise and Azure, but it wasn't really that sophisticated, and it's been improved a lot in 2016. For the remaining components in SQL Server, there weren't that many improvements, and the majority of the BI tools were largely unchanged from 2012. So 2016 sees Microsoft take those small steps that they made in 2014 and take them forward in a huge way. On the screen you can see some of the new features you'll see in SQL Server 2016, the relational database. Query stores, a feature that helps you troubleshoot performance issues. It stores the execution plans for every single query, and it lets you force an execution plan that works the best. Stretch database is a new initiative that allows tables to stretch into Azure. So your table splits into two parts, part on-premise and part on Azure. It's a good option for archiving data at a low cost and for a specified condition, for example, anything older than a year. There's a couple of new security features available as well. There's Always Encrypted, which ensures that the data is encrypted when in transit and in memory, rather than just when it's stored on a disk. And there's row-level security, which really simplifies the ability to give different users access to different slices of data. And we'll have demos coming up for both of these security features later. There's also a couple of new features that support big data and analytics. With Polybase, Microsoft have bridged the gap between structured and semi and unstructured data. Polybase allows you to query non-relational data using T-SQL by creating a connection in the background between the SQL database and the big data sources. And so it lets users query these sources using their existing T-SQL skills without having to know anything about Hadoop. There's also a new feature called R services, which integrates the R language that's used for statistical analysis into SQL Server. And later on we'll be taking a look at this in a bit more detail as well. There's also been a number of significant performance improvements in this version. As I mentioned earlier, they've made investments in 2014 with the release of in-memory OLTP. And in 2016 there's been a number of improvements to this. For example, you can store up to 2 terabytes of data in memory compared to 256 gigs in 2014. Operational analytics is Microsoft's offering for real-time in-memory analytics that removes the separation between operations on a regular transactional system and analytics. So in the background, the database stores 2 versions of the data, so that the transactional and the reporting queries run against different copies of the data. And this means being able to run real-time analytical queries and up-to-date data. And finally, there's a brand new feature called temporal tables, which is a time travel feature that allows you to easily report your data as it was at different points in time. This becomes particularly useful if you're using operational analytics and reporting from a transactional database, which might not have been designed in a way to store historical status as you would have in a data warehouse. And it's worth mentioning Tableau's endorsement of the performance gains in 2016 as well. So they recently published an article on how they ran some standardized tests with their reporting tool sitting on top of a SQL 2016 database and compared it to 2014. And they found an average query performance increase of 190%, with the biggest gains in the longest running, most complex queries. In one case, they found a query that took over 3,000 seconds in 2014, and it took just under 4 seconds in 2016. And of course, you won't find that sort of improvement in every case, and you still need to ensure your data is optimized, but it's still pretty impressive stuff. So we're going to start by looking at R services. Last year, Microsoft acquired Relational Analytics, which is a company that provided a commercially supported distribution of R, and R is a statistical analysis programming language, and they rebranded it to Microsoft R. And in 2016, they've now integrated it with SQL Server, which takes it to the next level in terms of how it can be used. So now you can invoke your R scripts directly from your SQL Server, and this allows for an easy and efficient way to pass your data from SQL into your R scripts, and also to use the results within SQL or reporting tools that sit on top of it. And also lets you productionize your R code really easily. So I'll be going on to a demo now, based on an example of a proof of concept we did for a CPG company. They wanted to use the survey data they had, which captured customers' preferences over a period of time, and they wanted to use this to identify the major factors that were changing. So the diagram here on the right shows a high-level architecture. The data from the flat files were loaded into SQL using an ETL tool, and there was a reporting tool sitting on top, as you normally would. But because we were using 2016, we also had the R calculation engine installed on the same machine and working in tandem with SQL. So I'm going to go ahead and show you implementation of the R scripts within SQL. So I've got Management Studio open up here, and we've got, this is the view that has the survey data that we want to do the analysis of. So you can see it's got various dimensions about the users that responded to the survey, country, their gender, age, various different descriptions of that person, and then measures about what their interest in the products was and how often they use the products. And what we've done is created a procedure here that takes 4 parameters. So these parameters would usually be populated through the report that the user runs. They select it through the interface and it'll be passed through here. So we've got the first parameter up there, compare. So here you can decide which dimension you want to compare on. So later on we'll be looking at comparing between different ages, but you can also look at comparing between different brands. And then we've got period 1 and 2. So this is saying which survey data you want to take, which periods you want to take them from, and compare the data to see the differences. And then finally we've got the country. So you can zoom in on a particular country and analyze the data for that. So below that in the procedure, what it does is a normal SQL select statement, taking the data that we want from our survey data and using it as an input. Then what happens below that is that we've embedded the R code that we use to carry out the analysis. And this is where usually in previous versions you'd have to have a separate server storing this code and running it on a separate server. But now we've just embedded it all into the stored procedure that's in SQL. Then finally the statements to return the output of the analysis. So I'm going to go ahead and run that demo. So run the procedure. So I'm comparing by age between January and February 2013, and I'm looking at the country of Spain. The results that it comes up with The comparison group column are the ages of the respondents that it's split by, and then you've got a count of people that we're measuring on in terms of their interest in the product between the first and second periods, so January and February 2013. Then it's calculated the change between these two periods, and then after that we've got a p-value. So the p-value is a statistical figure that's usually used by statisticians to get an understanding of how significant the results are. So usually you take anything that's below 0.05% as significant. Otherwise it could just be anomaly in the data, depending on your sample size. So what we can see here is the ages that have been marked statistically significant. So we can see 35-year-olds have got reduced interest in the product, and we've got a few more ages that have been spotted here as well. So what we'd want to do is, in real life, we'd probably cluster up the ages so we can analyze them between the different age ranges that we're interested in. Next, we're going to take a look at row-level security, and that's something that we've historically seen to be a major requirement in a lot of applications. This is all about being able to limit the slices of data that each user can see. So for example, you might not want salespeople from one region seeing data from another, or a product category manager to see reports on other categories. And you could implement this functionality in custom implementation to a certain extent with previous versions, but this was usually cumbersome and complicated. With SQL's new functionality, you can centralize the row access logic within the database while making it completely transparent to the users and other applications that make use of it. It lets you control both reads and writes, and you can use users' identities directly or their role or AD group, as well as taking other properties such as time into consideration. So for example, if a product moves into a new category, the manager of the original category can see data about it up to the point when it moved. And I'll shortly take you through a demo of this functionality, but before we do that, let's take a look at what needs to be done. So the diagram at the bottom shows the three main components. You've got your existing fact and dimension tables, and these usually contain the relevant columns that you want to secure on, for example, region. And you then need to create a function which defines which columns and parameters you want to use for security. Then finally, you've got a security policy that defines which function is used for which tables and what types of predicates you want to use. So we've got filter predicates, which just filter out the data, and then we've got block predicates which throw an error if you try to access a row that you're not allowed to. So now we're going to have a quick look at a demo to see what we do to implement that. So what we've got here is a database which has some retail data, and so we have a store table with a list of all the stores. And as you see, I can see all the data across the different regions, and this is what I want to apply the security on to restrict it by region. And we've also got a sales unit table, and this links to the store table, so it's got sales between stores, and I've just done a count here so we can see there's about 1 million rows overall in a table, and that should reduce once we put the security on. What I've also created is a users table. So I've inserted myself as someone who works in the Northeast and deals with biscuits. And to create the security for myself, so for the system, I've created a function here. I'm going to be creating this function here, which in there I've said I want to use the store number as something I want to secure. And how we're going to do it is by joining the users table to the stores table and finding which stores relate to the region that I'm interested in. So I'm going to go ahead and create that. And once I've got the function, I want to create a link between that function and the tables that I want to put the security on. So here I'm saying I want to apply this function to the store table and the sales unit table on the store number column, and I'm going to put both filter and block predicates. And then once I select from store again, you can see it's being filtered down just the Northeast region. And the sales unit data will be filtered down as well. We'll have about 190,000 rows. So, like I said, we could do this outside the system before, but really what's powerful here is that if I want to apply it to more tables, I'll just add a function again, add a line in the same policy, and it's all maintained in one place, and it's really simple to update, maintain, and make any changes. So now we're going to take a look at SQL Server's other big security feature, which is aimed at both stopping malicious man-in-the-middle attacks and limiting what users within your organization can see. For example, a DBA would traditionally have full access to a database, but that's not always ideal. There's some areas like HR data that you wouldn't want them to be able to see. So with 2012, Microsoft introduced TDE, or Transparent Data Encryption. This let you encrypt the data stored on the disk, but with always encrypted in 2016, we're a step ahead. So data remains encrypted in the RAM and when being transferred across servers, and it can only be decrypted by applications which have the correct certificate. So this stops man-in-the-middle attacks where someone sniffs out the data while it's moving. And I've found this of particular interest because I've recently been working on the financial system for a CPG company, and we've had to come up with a custom security implementation to ensure that the system was encrypted at all stages, at rest and in motion. And with this, we could do it a lot easier. There is an overhead to performance, so we wouldn't recommend using always encrypted everywhere, and you need to identify which columns and which tables are the ones that really contain sensitive data. But a huge benefit with this is that it's completely transparent to the end user, meaning that they don't need to know what's going on in the background when they're executing queries. So we're going to take a look at how we set up this encryption. We go back to Management Studio. And what we've got here is a database where I've created a similar table to what we looked at before, the users table. But in here in the database, I've also created some encryption keys. So I've created a column master key, and you can do that through the user interface quite simply. You give it a name, and it stores it in your personal store. And then I've created a column encryption key, and I've linked it back to the column master key. What the column master key does is now protect the column encryption key, and the column encryption key will be protecting my data. And then all I've had to do while creating the table is to add a statement to let it know that I want to encrypt the column user and what type of encryption I want to use and the key that I want to use for it. So then if I go ahead and query this now, you'll see the column that I encrypted, the user column, is completely unrecognizable. So it's been encrypted. For anyone who doesn't have access to keys, they won't be able to see it. So I'll hand over now to Arshad, who will take you through analysis services and the rest of the SQL stack.
Thanks, Ahmad. So we're going to look at the improvements made to analysis services in SQL Server 2016. And we'll split up our walkthrough of these improvements to analysis services into its two main modes, multi-dimensional cubes, which is a long-standing OLAP engine, and the tabular model, which was introduced in SQL Server 2012. With the traditional multi-dimensional model, analysis services sees incremental improvements to compatibility, connectivity, and performance. One of the biggest improvements here is that Power BI can now report from multi-dimensional cubes. This was a much requested feature in the developer community. Connectivity improvements have also been seen with the introduction of IBM Nategh app. In terms of performance, there's been quite a few improvements that have been made both over and under the hood. The Excel and analysis services teams at Microsoft have been working together to optimize how Excel generates underlying MDX queries to return results more quickly. Also, distinct count rollup optimization has been introduced for new data sources like DB2 and Oracle to enable better rollup performance. Drill through is another feature that sees improvement. It's been refined to consider multi-select, which thereby reduces the data set for which the query runs. But where analysis services sees its biggest changes is in the tabular model. It's clear that Microsoft are paying the tabular model a whole lot of attention, especially when you look at the extent of improvements that have come through with the tabular model in SQL Server 2016. Super DAX is what Microsoft are labeling the enhancements to the tabular model querying language DAX. With SQL Server 2016, DAX sees huge improvements with the introduction of over 50 new functions, as well as improvements to its formula editing interface and overall querying performance. Another welcome improvement is the introduction of many-to-many relationships. This feature has been available in multi-dimensional mode for some time now, but now sees its inclusion in the tabular model. We'll be demoing this very shortly. Some other improvements are the ability to process partitions in parallel and to set up folders for your measures. Direct Query, which is the tabular model mode that allows you to read data directly from the underlying data source, sees performance improvements. Microsoft have changed things under the hood to ensure that the number of queries run both by analysis services and at the underlying data source are reduced to a large extent. Direct Query also now sees MBX support, which now means you can query direct query models using your favorite end user clients. Row-level security is another introduction that is seen in SQL Server 2016 with the direct query models. Connectivity has also been expanded to include Oracle, Teradata, and APS. For non-English speaking users, translations should also be a welcome new feature in the tabular model. And finally, there's the introduction of tabular model scripting languages, which is a new scripting language for tabular models and replaces the traditional XMLA format. TMSL is in JSON, which is generally more efficient and easier to edit. So without much further ado, let's just go straight into a demo to show you what's new. So you should see on my screen now a very simple tabular model opened up. And I should say right at the beginning that this tabular model is built to demonstrate many-to-many relationships that are now available in SQL Server 2016. So many-to-many relationships was a feature that was available in multi-dimensional mode, but not in tabular model until now. And what I'll try and do here is explain the importance of many-to-many relationships in several enterprise implementations before showing how easy it is to create now in the tabular model in this release. So over here in this tabular model, I'm in the diagram mode, and you can see I have a customer table and an account table and a classic scenario for many-to-many relationships, which is a bank where you can have one customer having many bank accounts and one account with one or more customers. Therefore, many-to-many relationship between customer and account. To illustrate this more closely, I'll go over to the grid view and show you the contents of my tables. So my customer table sees Ahmad and Arshad, but you're not going to see any of our bank account details, so don't fret. And you'll see our account table has two types of accounts. It has a joint account and it also has individual accounts. We also have a bridge table which demonstrates how the relationship between customer and account is many-to-many. So Ahmad can have a joint account, and he can also have many other accounts as well. And finally, we have the fact table, which contains all of your deposit information, but only per account. So now if I go back to the diagram view, let me browse this model in Excel. And we haven't set up any many-to-many relationships here. So if I browse this in Excel, it should demonstrate the problem that we used to have in the tabular model without many-to-many relationships for this kind of scenario. So you'll see that I've opened up Excel, and in the pivot table field list, you'll see the fields in my model. If I analyze it by account, if I look at the deposits by account, the values should all be fine because my fact table has data by account. But the traditional problem that came without many-to-many relationships was in the tabular model was when you would browse by customer. So you'd see that the values are all skewed now. They're bloated and they don't necessarily match per customer because we have been able to establish a many-to-many relationship in the model. Previously, if you had to implement this in a tabular model, you had to do a pretty long-winded DAX calculation per measure. So it was a workaround, and there's some white papers on it, but it definitely wasn't easy. So Microsoft have been listening to the developer community, and what they've done now is they've made it as easy as just clicking on a relationship and specifying the direction of the filters to be bidirectional, which means that this relationship is many-to-one in both directions and ultimately many-to-many. So let's make it many-to-many for both tables, and go ahead and save it. And if I go ahead and refresh my data, what you should see is the correct values now showing up per customer. So as easy as it used to be to set up in a multi-dimensional model, you can now do in the tabular model. Outside of that, within Visual Studio, in this case with SQL Server data tools, you see some other improvements with tabular models. So you'll notice the interface looks a little more modern and different. Much easier to create relationships, much more intuitive. So if I just deleted this from the model, I can then go ahead and drag and drop relationships very easily, as simple as that. So much faster, a much easier developer interface and relationship in general. There are also some other new features, like the ability to edit DAX in a more intuitive way, which I'll get into. So let me go into my DAX measures. So if you look at the overall DAX measures, so you can see over here I have in my model, it's the interface for creating DAX is now color sensitive as well, and there's some IntelliSense, so it's easier to go about doing that. And you'll also see the introduction of translations. So previously, you weren't able to create translations for a tabular model, but now you can. It's as simple as going to translations and going to manage translation. So you'll see for this overall solution, what I've done is I've created a Spanish translation. So this is a welcome feature for non-English speaking users. So what I've got over here is a Spanish translation, but I haven't configured it yet because I need to import a JSON file in TMSL to set up the translation. So that can be done by going over here and doing import translations. So I've already imported a translation and I've created a JSON file. So this is the TMSL language of my translation. A very simple file. You'll notice it's not like XML, easier to understand, well classified. And what I've done over here is I've also created a single translation for the customer dimension. I've named it as Cliente, just to show you how it works. So now if I go back to my model and I go ahead, let me close my earlier Excel window because I opened that in English. So if I go ahead and browse the exact same model, but I choose the Spanish mode. So I'm choosing the Spanish culture to browse the model. It'll open up Excel again, and when I look at my pivot table field list, the field which I specified to be in Spanish now shows up as Cliente. So very easy using TMSL and the JSON format to go ahead and make those changes. Outside of that, so I was talking earlier about DAX, so now it's color-coded, so the syntax you can see over here, much easier formula editing. I can indent things which you couldn't do earlier. It's just more intuitive. And you can also create calculated tables. Very easy. It's just this icon at the bottom right in your grid view. I just do that, and if I want to create a copy of the customer table, all I need to do is type equal to customer and hit enter, and I've got a calculated table in less than a second. So Microsoft has been paying attention to the developer community and introducing these enhancements, so a lot of developers should be quite happy to see this. So that concludes the demo of the advancements to the tabular model. Let's now move on to what's new with the flagship ETL tool for Microsoft, which is integration services. So with SSIS in 2016, Microsoft have made advancements in 3 broad categories: manageability, connectivity, and usability and productivity. In terms of manageability, you'll see the introduction of package paths, which is a new feature that allows you to consolidate control flow elements in a package in a single reusable part that you can then plug into other packages. Microsoft have also made improvements to the debugging and logging capabilities of SSIS. Another improvement is the ability to deploy packages alone. So some of you will know that with SQL Server 2012, SSIS saw the introduction of the project deployment model. And every time you deployed to a catalog, you had to deploy the entire project and couldn't necessarily deploy only individual packages. With 2016, they've been listening to developers and they now allow incremental package deployments. So that's a pretty welcome introduction. Connectivity sees pretty big improvements, so there's more cloud and on-premise data sources that you can bring into your packages. And in terms of usability and productivity, in general, the interface it's nicer to work with. The install experience is much simpler, and also you'll see, if you look into each of the tasks, you'll see more enhancements and expansion of productivity over there. So without having to talk too much over the features, I'll get into another demo over here, because typically that's what people like. So let's get into the demo. So now I'm going to switch over to my integration services demo. Not a very complicated SSIS package on the screen. It's a very simple package, and it's meant to demonstrate a very simple advancement, but something that developers, I'm sure, will rejoice over. So in this package, we have a data flow task. And within this data flow task, it does something very simple. It reads from a customer flat file and dumps data rows into a SQL Server table. What I've got in this data flow as well is a dummy union all task to capture any error rows. So I've deliberately inserted an error row into my age column in my source file. My age column is supposed to be an integer data type, but I've put in some text in one cell to deliberately throw an error. And I've set up a data viewer on this error data flow just to show you exactly how the debugging is improved now. So let's go ahead and execute this package. It's called customer load. Very simple package. And the advancement in itself isn't something very big, but it's something that developers have been crying out for a while now. So while I execute the package, you'll see this new option or this new feature where you can now see the column name in my data viewer. So now I know exactly which column instead of having to go to the column ID. So quite useful to have. So my package is executed, great. In terms of other improvements that have come through, there's also the introduction of package paths, which is basically the ability to consolidate certain control flow elements in a package and deploy them to other packages. So if I'll stop debugging. So what you can do with package paths is you can save it as a .dtsxp file, which is a different extension. Your package is typically a .dtsx file, but you'll see over here I've created what is an archive block .dtsxp, which is basically a sequence of tasks that just archives a file after it's loaded. So if I just wanted to plug that into any package, you'd see it available in my control flow. In my other tasks, if I go to my package flow. So if I go back to customer load.dtsx, you'll see in my control flow paths in my toolbox the dtsxp file. So I just need to drag it and drop it in here. And this way I can reuse certain modules across a number of different packages. So easier to develop. The last feature that we'll demo, which is new with SQL Server 2016 and SSIS, is the introduction of custom logging levels. So previously, logging in SSIS was either too verbose or too basic, at least the logging levels that were shipped out of the box with integration services. Now you can configure a customized level of logging at your catalog. So over here you can see I have an SSIS catalog, and for my catalog I've got this. When I right click, you can see customized logging level. So for the purpose of this demo, what I've done is I've created a custom logging level. I've named it only errors, and in this level what I can do is I can specify the kind of statistics I want to log and the events for which I want to log things. So in this case I'm logging only for failures, for warnings, and for errors. You'll also see that I've published the same package I was executing earlier to the catalog, and now all I really want to do is I want to execute this package with the customized logging level. It's very easy, just right click and execute, but when you go to the advanced option, you select the customized logging level that you want to execute with, and you see the operation ID 23. I don't want to see the custom report that typically comes up when you execute the catalog from Management Studio. So I know it's executed because it's a very quick package. And I can see now in my executions table, oops, let me change my database. So what you can see is I'm going to change it to this one in the catalog schema, which typically configures these or it stores these logging statistics. You'll see number 23 in my execution statistics, and if you look at some of the other tables in the catalog schema, you'll see that it's only really log statistics for errors, failures, or warnings. So you can see the error output here, etc. You'll also notice the inclusion of a new table called customized logging levels, which will store all the custom logging levels that you've created in your catalog. So some nice features, just making life easier for developers in integration services. Now let's look at the other less central components of SQL Server, specifically master data services, data quality services, and APS, which is the analytics platform system. Right off the bat, we can tell you that there's no major improvements to DQS, but master data services definitely see some improvements. APS doesn't necessarily fall within this diagram we have here, as it's an extension to SQL Server PDW or Parallel Data Warehouse, but we'll get into what that is later and separately. With master data services, Microsoft have made improvements in three main areas. The first is with performance. So they've brought in data compression now, so it executes more efficiently. And they've also brought in new SQL Server jobs to make index and log maintenance much easier. Security is made easier to administrate, so you can extend admin privileges in a much easier way, and also connectivity has been expanded to include some new data sources. And in terms of manageability and maintenance, a very welcome new feature is the ability to share entities across models, and also some improvements in logging and debugging. Analytics Platform System, or APS, is Microsoft's large-scale data warehouse offering that competes with the likes of Teradata. It's an appliance, which means that when you buy APS, you're buying both hardware and software. APS is essentially what was formerly known as SQL Server PDW, or Parallel Data Warehouse, rebranded and revised, but with the ability to support hybrid scenarios. So with APS, you can now query relational and non-relational data in a single appliance. The connector that makes this happen is what Ahmad mentioned earlier, Polybase. And Polybase is the connector which Microsoft have created that allows you to query non-relational data using T-SQL. The scale-out capacity of APS is pretty big. It's up to 6 petabytes. Microsoft claimed that it's the lowest price per terabyte for any data warehouse in the industry. They've also made licensing pretty easy for existing customers in order to increase adoption. So to conclude this presentation, let's summarize the key takeaways from SQL Server 2016. What we see is that release cadence has improved with this release. Unlike earlier where you had to wait around 5 years before a big bang release, you will see that the gap is 2 years between SQL Server 2014 and 2016. Microsoft have improved SQL Server across the board, so it's not in one layer, it's in almost every layer. So analysis services in the core relational database see big improvements in scalability and performance. Reporting services, as Ahmad demoed, sees a brand new look and feel and paradigm. Microsoft have also looked to bridge the gap between relational and non-relational data with the introduction of Polybase as well as our services. APS is an indication that Microsoft is looking to be more competitive both in terms of price and performance when it comes to large-scale data warehousing. SQL Server 2016 sees improved extendability to the cloud or Azure, so there's options for Azure data backups and also stretch, as you can now see in the relational database. While release cadence has improved greatly for SQL Server on-premise, it continues to remain excellent for its Azure cloud-based offerings. So in essence, Microsoft's new roadmap sees them offering a data platform that can scale tremendously, can handle both structured and non-structured data, and works both on-premise and in the cloud. So it really fits any shape, size, or location of data. If you'd like to see these new features for yourself, feel free to download SQL Server 2016 Release Candidate 3 and install it now. So how can Thorogood help you? You can look out for our workshops in the UK and US where we take you through the entire Microsoft roadmap in a very interactive environment. Come along and feel free to challenge our consultants. We're also in constant conversation with customers who've shown an interest in SQL Server 2016 and are keen on understanding how they can integrate it into their enterprise technology architecture. If you need help putting together your own architecture while taking into account your own business challenges, or you need to implement an architecture, feel free to reach out to us and we'll be happy to help you. If you're interested in any other aspects of the BI roadmap for Microsoft, not necessarily SQL Server, so whether it's Azure, Power BI, Cortana Intelligence, feel free to attend any of our in-person marketing events in the UK or US. We also run regular webcasts and have a number of on-demand webcasts available on our website for your viewing pleasure. At Thorogood, we host a number of educational marketing events across a range of different business intelligence tools and topics. Our next event is a workshop in London on how you can leverage the strengths of Tableau to build intuitive dashboards and gain valuable insights for your enterprise. We're also running a workshop on the Microsoft Technology Roadmap on May 19th in London. So if you're around, please register if you want to learn more about Microsoft's hybrid strategy. For more details on other upcoming events, feel free to visit the link at the bottom of this screen. Thanks very much for attending our webcast. I hope you found it useful and interesting. If you have any questions, do reach out to us via telephone or email that you can see on the screen. Thanks again and have a great day. Cheers.